C Inc., presented by its CEO, Masayuki Kanehara.
Oh, hi, nice to meet you, everyone. So this is a printed circuit board. Everyone knows that. This is nowadays indispensable for all kinds of electronics. Nowadays, printed circuit board manufacturing process has this kinds of the multi-steps and using the highly toxic chemical materials. So this has three kinds of problems: pollution, high cost, and slot production. So such kinds of conventional process needs a multi-step production. So this needs many production facilities. So the initial and the line cost is bad, but fine pitch is possible. So all kinds of the electronics needs a conventional system. So alternative is printed electronics. This can make the electronics material such as printed circuit board using the printer. So but printed electronics needs initial investment and the line cost is good, but fine pitch is almost impossible. So not so good solution now. So but C-ink technology totally can change the world. So our inkjet-based technologies, we are the nano-ink manufacturer, metallic conductive nanoparticle-based ink. So our nano-ink is quite unique for stable inkjet printing. And our ink is a water-based system, so low cost is possible. And our special printing system can offer 30 micrometer, like a very fine pitch. So this covers the high-end printed circuit board, right? So our process is very simple. This is world's first example of already commercialized full additive process. So not different from the conventional printed circuit board system. Conventional system is a subtraction and etching-based system. Our process is full additive. You mean that? So just two steps. So first, printing the silver nanoparticle on the substrate, then electrolysis copper plating. Just the two processes, you can make the copper patterning and this. So that's first and sustainable low cost. So but not only low cost, but the quality and the reliability is quite nice. So we already have a big electronics company in Japan. So this is a brief introduction and demonstration using our nano ink. So this home printer, not expensive. Actually, the $50, 50 USD printer. So, but you can see here, very nice inkjetting is possible. All other suppliers now ink always cause nozzle closing. Don't worry, things is very fine. And this is this substrate is a white PET plastic PET substrate. And after printing, so this is dryer, and you can see. After drying you can see the metallic rust there. It's a gold-like color, but this is silver nanoparticles. So then dipping into the electrolysis copper plating solution. And then wait 5 minutes. Now plating. So you can see that no copper trace outside of the silver nano patterned area, just on the silver nano printed area. So we can make the copper trace, copper patterning. And this is a copper trace already. No heat treatment, high temperature system. You can make the copper trace very simply. And the conductivity is very nice. Like this kinds of already applicable value. Okay. So as you can see here, printed circuit board is necessary and indispensable. And market value is quite big. So about 70 billions by 2022. So actually, C-ink technology is a quantum leap, both for metallic nanoink and the printing system. And the sync-based system is now changing this production by using the full additive process. The sync will be the infrastructure of this field. Oh, okay. Thank you for your kind attention.
I love the accelerated time, CTO, which was fantastic. Okay, let's go for questions, because I'm starting the 4 minutes already. So, who has questions, please? Yes, one here. Please, a second one to the back.
Thank you very much. I've really liked the technology. How do you mount components on that?
Component?
On the circuit board, right? Like a PCB, you have components that you solder onto it. How do you mount components on these circuits?
Yeah, so standard soldering is possible. Because this is a copper trace. Actually, this demonstration using the PET substrate. So if we want to mount and such the parts, electrical parts on the copper trace, so you can use PI like a high temperature resistive substrate. It's possible.
Okay. Second question back there. I recognize the presenter of this morning.
Which materials can you print with this technology? And after that, is it flexible?
So usually, my customer is a flexible printed circuit board manufacturer using the PET. One is PET and one is PI for flexible patterning. And for example, another application for the high frequency application. So liquid crystalline polymer film a special substrate also can be used. So you can use any kinds of plastic substrate.
Third question was here. Yes?
I mean, it's very impressive to see this coming out of a conventional printer. But what is now really the benefit for the manufacturers? Why would they care of switching from an already very cheap PCB to your solution?
Yeah, sure. So not only the small and amount production, but also the large scale production, both. So we can offer the customer the inexpensive but reliable PCB. It's answer for you? Okay.
That we have already today, don't we?
Today?
Yeah.
Today? So you mean that already commercialized? You mean?
No, but what we use today is already quite cheap and quite reliable.
Yeah. Of course. So because many company devotes effort to reduce the cost, but we can reduce more. Because printed circuit board, the function is very simple. Just connecting the electricals each other. The customer can choose the cheaper, inexpensive one if quality and function is same. So that's our technology that's chosen by the big electronics company.
Your question mark fell on the floor, and then we have the fourth question here directly in front. Hello? You had a question?
Yeah, mine was just around cost, because unless it's cheaper, you probably wouldn't be able to displace the conventional methods. So what's your thoughts on cost?
So comparison? So about 20% less inexpensive. Yeah, it's possible.
Okay.
It's a great reduction.
If somebody has a 30-second question and answer, I give it to you, otherwise. Okay, we're done. Thank you very much.
Thank you.
Okay, and the next presenter, go up. Yes, thank you to leave the clicker for the